Firstly, I would like to introduce about the optical communications. Optical communication govern long-distance point-to-point extraordinary capacity links. The increasing necessary for bandwidth and message data processes retain accepted optical connections measurable to shorter and shorter distance with data links comprehensively engaged between platforms. The improvement of silicon-based optoelectronic integrated circuit consists of electronics, waveguides, passive optical device, and optoelectronic device based on transistor are in approach. Research program. One research program is in designing out optically controlled FFT transistor based on crude form material to observe the high performance quotation in device fabrication. Objectives. The objective of this study is to find the heterojunction structure for OCFET with numerical analysis. The first analysis was done with energy band diagram consideration for device modeling with mathematical expressions. The second portion of analysis is to acquire the collection efficiency at Geiso junction in OCFET structure based on eggplant in numerical simulation. The third simulation result were optical characteristics of CD-contaminated heterojunction based material for developed OCFET structure. The figure is the device modeling for fabrication of OCFET. Implementation. The implementation procedure were complete by using numerical analysis, and this implementation were implemented according to the respective flowcharts shown in the following slide. The figure is the flowchart of energy band diagram calculation. Firstly, initialize the physical parameters of the target material for OCFET, and then energy band value and width of depletion layer in anti-semiconductor and p-semiconductor were applied to develop the physical value of energy band diagram for the OCFET. This figure is illustrating the flowchart of collection efficiency calculation. At first, land on nanowire in gate terminal carrier fee MIPAT illumination value are declared for collection efficiency calculation process. And then that value are calculated based on the different value of length. That figure is shows the flowchart of drain to source current in OCFET. At first, initialize the physical parameter of OCFET. After that, calculate the kinetic of IDS in OCFET. After the calculation of IDS, we assess the calculation of source to drain current. Now, I would like to present the results of my research work. According to the diagram for OCFET based on the silicon and germanium materials, that figure is the collection efficiency versus land or nanowire engaged terminal. According to the simulation results, the collection efficiency is dependent upon the length or nanowire in the engaged terminal. If the value of length increase, the value of collection efficiency will be increased. That figure is illustrate the drain to source current calculation based on carrier mobility. According to the simulation results, the carrier mobility rate is increased, the drain to source current will be increased. Let me conclude my presentation. The calculation of energy band diagram collection efficiency are very important to consider the physical properties of OCFET. And moreover, another consideration is optical properties in OCFET. In this study, the three considered parameters for OCFET development and fabrication process were mentioned first. According to the experimental results in research article, the simulation result were accomplished and obsessed. The result in the study confirmed that the performance of proposed OCFET were met the device fabrication in real-world application because of the numerical results in simulation approach. Thank you very much for your attention.